Hello my dear students, once again welcome to your physics online class. Today we will be beginning a new chapter of your physics textbook, that is the 6th chapter of your book, and the chapter's name is Heat and Energy. We are very much familiar with this word heat. We have been studying the heat is a form of energy, and today we will try to understand a little bit deeper thing about the heat, like we'll be understanding a basic concept of heat. So we have already learned in class 8 that with the rise in temperature, what happens, the molecular motion also increases. So if you have a certain object which has many molecules in it, okay, so we have learned that if suppose initially it is at 10 degree centigrade, now you supply a certain amount of heat to it. So on supplying a certain amount of heat, what happens, its temperature rises. Suppose it becomes 30 degree centigrade. But on doing so, what is also changing? The motion of these molecules are also changing. Suppose if used to vibrate smoothly, what happens? On heating, it will vibrate rapidly or with a greater amplitude. Okay. So molecular motion is basically, it is the, like whenever something is in motion, it poses a kinetic energy. Okay. So suppose if you find the kinetic energy and the potential energy of each of these molecules and you add it up, then that energy is said to be the heat energy. So thus we can say that the heat energy is the measure of the internal energy of a body. Here the internal energy means the sum of the kinetic energy and the potential energy. So heat is due to the molecular motion of a body. So understood? So what is heat? Heat is basically the measure of the internal energy of any object. So now coming to the unit of heat, the heat is generally measured in joule, okay, in SI system, and then it's measured in erg in CGS system. Okay, so apart from this joule and erg, there is most commonly used the general unit of heat, that is known as a calorie. Okay, so now to define 1 calorie, so how much is 1 calorie? The 1 calorie is the amount of heat required to rise the temperature of 1 gram of water by 1 degree centigrade. So whenever you change the temperature of 1 gram of water by 1 degree centigrade, whatever amount of heat you are supplying, that is said to be a 1 calorie. So now coming to the third term, temperature. Okay, so temperature is simply a hotness or a coldness of a body. Also, we can now understand the temperature in this sense as well. Suppose if I have an object A and an object B, okay, so one is hot and the other is cold, and we know that the heat always flows from the hotter body to the colder body. Suppose in this case A is hot and this one is a cold. Okay, so the heat will flow from A to B. So the parameter that tells us in which direction the heat will flow, that is said to be temperature. Okay, so temperature is a parameter that tells us the direction of flow of heat, or simply we can say the temperature is the hotness or a coldness of a body. So now there are 3 units to measure the temperature. The first one is the degree centigrade, the second one is the degree Fahrenheit, and third one is the Kelvin. And we have already learned the conversion of one unit to the another in class 8. So you may revise your class 8's book as well. So out of this, the Kelvin is considered to be the SI unit of temperature. So remember that. Now the fourth topic is the thermal expansion. This also we have already studied in class 8. So what is the thermal expansion? The thermal word, it comes from heat. Okay, so it is seen that whenever the substances are heated, it increases in its volume. So that is known as a thermal expansion. So if the expansion caused in an object is due to heat, then that is known as a thermal expansion. Now coming to the anomalous expansion of water, just now we learned that whenever any object, whether liquid, solid or gas, when it is heated, it increases in its volume. But here, like water, if you take a water at 0 degree centigrade and start heating it, so what happens? Initially the volume of water, it decreases, but after 4 degree the volume of water starts increasing. So that is known as a anomalous expansion of water. Suppose in a beaker, if you take a water up to the level A, okay, now the water is at 0 degree centigrade. So when you start heating it, what happens? The 0 will become 1, 2, 3, 4, 5, 6. But when it changes to 1 degree, so now when you heat a water, what happens? So instead of increasing in the volume at 1 degree, the volume decreases to level B. 2 degree, the volume will still decrease. 3 degree, the volume will decrease. 4 degree, the volume will decrease. But once it crosses 4 degree centigrade mark, after that the volume of the water starts increasing. So at 5 degree it increases 6, 7, 8, 9 and so on. Okay. So the anomalous expansion of water simply means that water initially when heated, its volume decreases up to 4 degree centigrade, and after 4 degree on further heating its volume increases. So if you are asked to plot the graph of the temperature and volume of a water, so what can I do? Suppose if you take a volume V liters of water at 0 degree centigrade, so 1, 2, 3, 4, 5, 6, so this is 4 degree centigrade, 8. So initially when you heat at 1 degree, instead of increasing the volume decreases, 2 also decreases, 3 also decreases, 4 also decreases, and 5 it starts increasing. So you will get a graph of like this, the anomalous expansion of water. So this is the volume versus the temperature. Similarly, if you plot the temperature and the density, since we have learned that the density is equals to mass by volume, so the density and mass, they are inversely related. So lesser is the density or lesser is the volume, the higher will be density. So at 4 degree, okay, so this is the temperature and this side if it is the density. So it will have a maximum density like this. Okay, so at 4 degree the water has a maximum density. Now coming to these consequences of thermal expansion, anomalous expansion of water. So it is only because of anomalous expansion water that the aquatic life can survive in a cold countries. So you have seen that the upper layer of the pond it freezes, but the lower layer it still remains the liquid. It is because of the anomalous expansion of water. Okay, so it's given details in a book, you may go through it. Now the sources of energy. Coming to the sources of energy, we consider the sun as the ultimate source of energy, because in absence of sun the life on earth would not have been possible. So the sun is the ultimate source of energy. So apart from sun there are various other sources of energy, okay, like a wind energy, the heat energy, the solar energy, the nuclear energy, the hydroelectricity. The energy that we can obtain from a running water is known as hydroelectricity. And also remember, this energy, it can be converted from one form to the another form. So everything is given in details in a book, so you may go through it. It's very simple for you to understand. You also have a merits and demerits of each of the energy as well. Now coming to the renewable and non-renewable sources of energy. So the name itself suggests the renewable sources of energies are one which even if it gets exhausted, means if it khatam ho gaya, okay, so it can be renewed in a very short period of time. But the non-renewable sources of energies are the one which once exhausted, it will take a long time to reform again. Okay. So now there are various advantages of renewable sources of energy over a non-renewable sources of energy. That too you can go through your books in details. Okay. So this is all about the today's class. In the next video, we will be learning about the energy degradation, the global warming and the greenhouse effect. So till then, okay, so this portion, the sources of energy, through your book you go in details. Thank you.